Hi space lovers, today we are with French astronaut Jean-François Clervoy. He did 3 missions in space, he developed the zero-G flights in Europe, and he is the chairman CEO of Novespace. Jean-François answers some of the questions you asked. Let's go! Hello Jean-François, and thank you so much to answer our questions today. Could you please introduce yourself in a few words?
Hello, good morning all. So I'm 60 years old and I have, I think, the record of active status because I was selected very young at 26 years old. I am one of the rare astronauts who retired when reaching the age of retirement, which is 60 years old at the European Space Agency. So that's more than 33 years of astronaut professional activity. I flew 3 times in space, 3 times on board the space shuttle. Atlantis first to study the atmosphere, the second time also on board Atlantis to dock and resupply the Russian space station Mir, and the third time on board the space shuttle Discovery to repair the Hubble Space Telescope, which was totally failed as opposed to all the other missions which were for maintenance and not repair. I was in charge of robotic systems at NASA. I was in charge of developing the man-machine interface of the space station, the cockpit if you want, but the cockpit, you know, it's not like a cockpit in an aircraft. It's a network of laptops, 20, 30 laptops spread around the whole space station that serve as a cockpit. And I was a senior advisor astronaut of the European cargo resupply ship of the space station, the biggest ever spaceship to resupply a space station. It's called the ATV. The first one was named Jules Verne. That was my idea to give the name because it was a totally new kind of ship made by Europe, 21 tons, docking to the space station with a precision of less than 1 centimeter. Besides all this, when I was training as a flight test engineer, I made my thesis on what we call parabolic flights. These are flights with aircraft during which we reproduce for real weightlessness. It's not a simulation. We literally put the aircraft into the arc of an orbit. And I started managing the first European parabolic flight program in Europe more than 30 years ago. And during the 10 years I was stationed at NASA, completely involved in the 14th group of NASA astronauts. I delegated the program, the zero-G program, parabolic flight program, to a subsidiary of the French space agency called Novespace. And after the Challenger accident, after the Columbia accident, when I realized in 2003 that my 4th space flight, which was planned to the Hubble Space Telescope again, was cancelled, I suggested ESA to detach me for half of my time as the chairman CEO of Novespace, the company that was running this zero-G flight. And still now, I'm still the chairman of the company, and I am involved in all flight campaigns we do with this aircraft, and we will talk about it. We do fun things. We do a lot of science, but few flights are for fun, for individuals, but also for companies who privatize the plane for movies, like Tom Cruise flew 4 times with us for the Mummy. Champagne MUMM, they flew several times to qualify a bottle that can serve champagne in weightlessness, and I had the opportunity to race with Usain Bolt and moon gravity in our airplane. We also flew a few flights where we transformed the plane into a nightclub in zero-G, for real.
Okay.
So that was amazing, for a private company in Germany called BigCityBeats. So my career is basically engineer in astronautics at the French Space Agency, astronaut for 10 years at NASA with 3 space flights, expert on human space flight program for the space station, and also across all these, I was the father of the first zero-G flight program in Europe.
Okay, all right. Thanks for this introduction. Now let's talk about your path to become an astronaut. So, why did you want to become an astronaut?
You know, you don't become astronaut by chance. I mean, nobody comes to tell you, you know, we would like you to become an astronaut. So all astronauts are people who have decided by themselves to respond to a call for candidates. And when I was a kid, I wanted to go to space, but I never wanted to be an astronaut. Astronaut is a job. But when I was a kid, I thought that going to space was going to be a very regular, once grown-up adult person. But because my father was a fighter pilot, because I was a teenager, you know, when Apollo 11 allowed the humans to walk on the moon for the first time, I always got interested in space. And when I was 15, I started making my own air models, and I was a big fan of remote control aircraft. I did a lot of aircraft modeling, remote control, and as I was doing my studies after the lycée, after school, I wanted to be a telecommander of space probes. I wanted to design, as a job, spacecraft that go explore the solar system. And I wanted to be in charge of the autopilot of those satellites and in charge of managing the way we send commands to allow the spacecraft to do what we want here on Earth, then to do, you know, billions of miles from Earth. And that's what I did. I started working on a French-Russian spacecraft mission called Vega. It was a Venus and Halley Comet exploration mission. I worked also on the Hermes project. And then I was selected as an astronaut only 2 years after I started to work as an astronautician, you know, expert in astronautics. And when there was this call for becoming an astronaut, I thought, you know, I am a skydiver, I am a private pilot, I like to explore, you know, and go walk in desert areas. So I thought, you know, I am an explorer, in fact. I didn't realize I was an explorer in my heart until people tell me, you know, there is a call for being an astronaut. That's for you. You are programmed to be that. And I thought, yes, that's true. So, and that's the way I started going through all the exam and the tests, which are spread over 1 year. It's every 2 months you go for 1 day or 2 to a place to do a psychological test, you know, IQ test, intellectual, psychomotricity test, then medical test, then space physiological special tests like the rotating chair or the vacuum chamber or the tilting table. And then you end up by the very expensive test when the filter is kept only like 30 people, which are like the centrifuge, which is very expensive. And at the end, they kept me, so I was lucky. So to summarize, to become an astronaut, first, you need to feel inside yourself the will to do so. It must come from inside yourself. You don't try to be an astronaut just to try. I mean, that's something you feel. It's your calling. It's your destiny. Then you have to have the chance to be born in a country which has a human space program, at the right time, because there is a selection only every 15 years in Europe, and we select people between typically 28 and 34 years old. Officially, it's 27, 37. In practice, it's more like between 30 and 35. So, if you have everything right, but there is no selection while you are in between the 28 years old and 35, 36 years old age range, but that's you're unlucky. So in the right country at the right time, with typically a double master or PhD or high level of studies, whether it's in an operational job like piloting, submarine, skydiver, or I mean scuba diver, or submarine officer. We have submarine officers, or as an engineer, or in a wide range of science disciplines. Basically, you know, you need to have a high level of education that is still more on the math side than on the literature or lawyer or side. And at the end, you need to be lucky, because when the selection process is finished, almost finished, we declare about 25, 30 people, all equally fit for the job. But we select only 6, 7. So why me and not the one next to me? So that day I was lucky. You know, there is not today a study roadmap to become an astronaut. You cannot tell, like for medicine, you know, I want to do that job, so I know I have to do this study, this and this. For astronaut, we select people who have already a job, and in a wide range of disciplines. The astronaut job consists of operating complex machines in hostile extreme environment. This is just that. We are operators. Operating machines means learning how they work, how to operate them nominally and in off-nominal situation. But we don't do research, as opposed to what you might hear. Astronauts spend 70% of their time on board the ISS to operate scientific instruments. But astronauts are not the ones doing the research. The people getting the data, analyzing the data, and publishing articles in magazines are the scientists on the ground. So that's why initially, 50 years ago, 60 years ago, we selected astronauts among people who were already operators of complex machines, fighter pilots. But with the era of the space shuttle, we opened the selection to a wider range of professions, since still within the operators, but wider than just fighter pilot. We have a helicopter pilot like Team Peake. We have an airline pilot like Claude Nicollier, Swiss, like Thomas Pesquet, French. We have also a scuba diver. We have Navy SEAL. We have submarine officers. But we select also among a wide range of engineering disciplines, engineering propulsion, in material, in electronics, in computer science. And we select among a wider range of scientists, oceanographers, volcanologists, veterinarians, biologists, physiologists, chemists, astrophysicists, nuclear physicists, heart surgeon, all kinds of scientists. Because in space, all disciplines of science have something interesting to do in terms of research due to weightlessness and due to the very specific, perfect vacuum we have outside. So this is why when I was selected in 1985 in the second group of French astronauts, among our group we had 2 test pilots, 1 engineer, myself, 2 medical doctors, 1 veterinarian, and 1 material physicist. So once you are selected, you feel you have 1 foot in space. It's very exciting. But once the chief of the astronaut calls you in his office, and you wonder if you did something wrong, and he tells you, you know, Jean-François, I would like to assign you to this mission, 10 months from now. Wow.
Yeah.
This is a big excitement. This is almost more exciting than the day of launch when we go to the launch pad. Because the day you are told that you are assigned to a crew, you know it's going to happen.
I have a question about it. I have a question. How did your family react when you were selected as an astronaut, and especially your twin brother?
When I was selected, I knew it in July, but I was told to not tell anybody because it was going to be announced to the press only in September. But of course, I told my very close family members, including my twin, and he was very excited for me. He was engaged already into medicine. He was an adventurer like me because he did skydiving like me, he did scuba diving like me. He did do piloting training, but he was very, very happy for me because me being an astronaut going to space was a big part of him going also to space. So he was feeling like being part of this adventure.
You previously talked about the astronaut training. In your opinion, what was the hardest thing during your astronaut training?
You know, I never felt there was anything hard. When you look at the movie The Right Stuff, you see a lot of physical torture machines to train astronauts. This is terminated already a long time ago. When I joined the 14th group of NASA astronauts, the group 14 in 1992, there was no physical training at all. I mean, we have one run in the centrifuge to experience what it looks like to go to space, the 8.5 minutes of ascent. So the takeoff is 1.5 Gs. It goes up to 2.8 Gs on the x-axis of the body, so you are compressed from forward back to on your back of the seat, of the bucket. And then the last minute is back again to 3G constant. And 3G, not head to feet, but your body pressing on your back is quite comfortable. I mean, anybody can bear that, can sustain that. So we have one run in the centrifuge, and we have 2 sessions of 2 hours long, blocked in our weekly agenda to go to the gym and exercise the way we want. So I enjoy playing squash. I used to play squash for 2 hours, or sometimes jogging. Astronauts know that it's good to be fit physically, not to be a high sportman or woman or to be a champion. Just good to feel fine in your own body and exercise regularly like you would do normally in a normal life, and that's enough. The training consists mainly of briefing by engineers who designed the spaceship and the systems, and astronauts who have already been in space using those systems, so getting the space flight experience from senior guys, and then learning in books like you learn when you study engineering. And then we go into simulators, and in the simulator we start with simple simulator, single system simulator. Then we go into full flight simulator, which mimic exactly the behavior of the system of the space shuttle. So the cockpit is the same. We have the same 1,000 switches in the cockpit, and the simulator is connected to the real flight control center as if the data was coming from a real space flight. And in between, you have instructors injecting malfunctions. We don't know in advance what will fail, neither the ground, the control centers, controllers, neither the astronaut in the simulator, and we have to find a solution. They are not allowed to give us a scenario with no solution, but they can be very mean to us. Sometimes we have a propulsion leak, air leak, fire on board, short circuit, the control stick which doesn't respond, and we have to find a solution. I would say when you start learning that is when it looks the hardest, because combination of malfunctions can be so complex that you may be fooled by a sensor which fails, but you don't realize the sensor fails and you think this is a system behind that failed. So you have to think that the system is tricky, and intellectually this is the hardest part of training. Is to get to the point that when the spaceship feels like an extension of your own body and not like something different or separated from yourself. And few weeks before flight, I would say typically 2 months, as a crew we feel Superman. We feel the spaceship is our own extension. We feel the beat of each system. We feel exactly what's happening. So it's and it's not the ground calling us in the simulator anymore first, like Atlantis, this is Houston, we see this temperature moving that way and this voltage going low, we think you might have a problem there, get ready to go page 10 of the checklist, blah blah, to do this. And we answer Houston, Atlantis, we copy, we are ready to listen. But close to the flight, we are so good, we detect first what's going to happen, although we have less data than the controllers in the flight control room. So we call Houston, here Atlantis, we feel we are going to lose that system because we see this and this temperature and this sensor. We think we are ready to go page 20 of that checklist, tell us if you're okay. And we are right. So we are ahead of the flight controllers on the ground, and we feel we are ready to go to space. So I would say, to answer your question, the hardest part in training is to get to the top intellectual level of competence and expertise that makes us feel totally at ease with the mission and very serene in terms of ability to save our life and the mission in any circumstances.
Okay, great. Now let's talk about your space missions, because our followers have a lot of questions about them. So first, how did you feel during the takeoff?
On my first launch, I was surprised by nothing, because as we talk a lot with our senior colleagues, we construct a picture in our mind of how it will feel that is very precise. And the launch, the ascent, which lasts 8.5 minutes, was exactly like I had pictured myself in my mind. You are excited, you are focused. In the case of my first launch, not the two others, but I was on the mid-deck, so no responsibility as far as controlling the spaceship. My only responsibility was to do critical tasks in case we had to bail out in flight. Because after the Challenger accident of 1986, we modified the cockpit and the mid-deck of the space shuttle in order to allow the scenario of jumping out in flight in case we cannot join a runway. I felt the pressure on my back. You know, we are sitting like in an aircraft, except the aircraft is pointing the nose up to the sky. So you lean, you rest more on your back than on your thigh, than on your legs, you know, like in an aircraft. And the pilot was calling in the intercom the altitude. And the altitude indicator runs through 3 different units. Initially, it is feet, then it is kilo feet, and then the altitude is measured in nautical miles. So the units change a few times. It's the same for the velocity, by the way. For the velocity, we have knots, and at a certain level of knots, we have a Mach number. The Mach number is a number of times we fly the speed of sound. And above Mach 5, the velocity is expressed into kilo feet per second. So when you're on the launch pad, you go up. After the sensation, the feeling of having a huge power under your butt, I mean under your back, you feel you go somewhere. You don't know where, but you go somewhere because you feel the push. And after 2 minutes, we are flying still vertically 5 times the speed of sound. The sky becomes black. There's only a very small window from the mid-deck on the side, and the launch was midday at noon. And when you are high enough, the color of the cosmos is black. You don't see stars, it's just dark, emptiness, black. And after 8.5 minutes, you hear the pilot calling the countdown to MECO main engine cutoff. You are compressed with 3G on your seat, on your back, and all of a sudden, we go in weightlessness. It is abrupt. And a colleague had told me during my quarantine phase, the week before flight, we are isolated in quarantine in our crew quarters. And Story Musgrave, a friend who had flown already 5 times, told me, you know, since you are on the big deck, you can afford to close your eyes and tell yourself you are walking along a cliff with a very, very heavy backpack on your back. You feel very heavy. And suddenly, you make a false move, a wrong step on the side, and you start free falling off the cliff. Because weightlessness is free fall. Weightlessness is not the absence of weight. It's when the only force is weight. When the only remaining force on your body is gravity. And nothing else to stop you from free falling freely. Nothing to slow you down like the atmosphere when you skydive. You know, after a few seconds, your regular descent speed is 200 kilometers per hour, 50 meters per second, because of the air cushion. But when it's vacuum, nothing slows you down, and you just free fall forever, unless something stops you. So, of course, if you free fall vertically, at some point something will stop you, the atmosphere and then the earth. But if you have an horizontal velocity of 28,000 kilometers per hour, horizontally, the free fall trajectory has the same curvature as the Earth, the same curve. So you free fall forever, indefinitely, until you do something to come back. Basically, what you do to come back, you just slow down a bit your velocity using your rocket engines on the spaceship so that the natural free fall trajectory will not miss the Earth continuously, but will intersect the atmosphere and the Earth because the trajectory will be a bit steeper downward. So, on ascent, nothing different from what I predicted. The push on the back, the black sky, the sudden, the sudden transition to weightlessness, and then going to the window on the flight deck, like 15-20 minutes after liftoff. I had to take some pictures from the cockpit windows. We were above Europe. So we took off at noon in Florida, and at noon and 20 minutes, we were flying above France and Germany. France was still illuminated by the sun, Germany was already at night. The terminator, that's the name we give to this line separating the day side to the night side of the Earth. The terminator at that point was in between France and Germany. And over Germany, there was a huge thunderstorm. I mean, few hundred kilometers wide. And we could see the masses of cloud illuminated from inside by the lightnings. So my first scenery of Earth seen from space was a very large, maybe 200 kilometer wide thunderstorm with very energetic lightnings. We could guess under the clouds because we could see like a big mass of cotton illuminated from inside, here and there, like if the lightnings were transferring their energy from one side to another location to another location. It was like if the different masses of clouds were talking to each other using lightnings. It was magic. It was like Earth is powerful. Earth has its own powerful meteorological life, climatic life. Then in the course of that first mission, we saw volcanoes starting erupting, like the Sakurajima in Japan. It started erupting 3 days after liftoff. You realize Earth is powerful. Earth is not fragile, like you hear many of us say. It's a very short way to remind that we have to take care of our environment. But Earth has its own climatic, tectonic, cosmic life. When you see impact of asteroids, like in Canada, you can see a huge landmark left by a huge asteroid a billion years ago on Earth. And you realize Earth is an object that is in the cosmos and will be impacted in the future again by big asteroids. It's rare, but it happens. Now, what is fragile is us, the life, because when you look at Earth on the horizon, when you look on the horizon about 2,500 kilometers from us, beyond that distance, it's behind, so you don't see, it's behind the horizon. You see the atmosphere from the side, you know. You don't see it from above, but you see it from the side, 90 degrees horizontally, and you realize it's very, very thin relative to the side of the Earth. Compared to a globus that sometimes we have in our home or in our desk, about 30 centimeter diameter, taken to the scale of this kind of globus, the atmosphere is typically the thickness of a sheet of paper. It's very thin. So this is when you realize life, plants, animals, us, we, humans, depend on a very, very thin layer of gas. And this is when you realize how fragile is the current equilibrium of our ecosystem, which allows us to be on this planet. But coming back to the overall mission, I want to remind the characteristic of this first flight. We were studying the atmosphere. That means two characteristics. We were flying most of the time upside down on our back. That means I was watching the Earth through the overhead windows in the cockpit, which are on the ceiling. And we were on a high inclination orbit above the equator plane, because that means from Florida, we launch in direction more to the north than due east. So we don't benefit much the centrifugal effect of the Earth's rotation. That's why our altitude was quite low, 300 kilometer altitude, but we reached latitude of about 60 degrees. That means our field of view could reach almost the polar circle, typically. On my second space flight, resupplying the Russian space station Mir, the orbit is less inclined above the equator plane, so we benefit a bit more of the centrifugal force of the Earth's rotation, so we could fly higher. It was 400 kilometers. And what was nice is docking to a space station, docking to a spaceship that is already there in space, with people inside, is very moving. When you open the doors, it's very moving. So we exchanged 4 tons of equipment, clothing, food, spare parts, also a huge, big 200 kilogram system which converts urine from the, water from urine into oxygen, and also 1 crew member. And my third space flight, to repair the Hubble Space Telescope, what was at twice the altitude of my first flight, because we launched due east. We want to benefit to the maximum extent the centrifugal force of Earth's rotation, because the Hubble Space Telescope has no propulsion system. It's just an assembly of metallic pieces, electronics, and optics. It is purely free-falling. There is no way to change its orbit when it's flying by itself. So, in order to prevent the telescope coming back due to atmospheric drag, because in space, even at 300, 400, 600 kilometers, there is still atmosphere. Very rare, very, very low pressure, 0.00000 bar. But there is still atmosphere. So at 300 kilometer altitude, if the telescope had been there, within 1 year, it comes back on Earth. But at 600 kilometer altitude, it will take more than 10 years for the telescope to come back naturally by slowing down the velocity due to the atmosphere, the residual atmosphere. But in between, we have missions to reboost the telescope. So it was a low inclination orbit. It was very close to the equator. I could see only a few thousand miles north and south below the equator. But I was at the highest altitude ever in human spaceflight, not counting, of course, the Apollo missions. So 3 different missions. The first one dedicated to Earth, with the best orbit combination to look at the Earth. The second, very moving because for humans. And the third, the best mission for serving science, because it was on this mission the Hubble was totally failed. And when I released the Hubble Space Telescope in space, I was in charge of flying the robotic arm. On Christmas Day, the ground told us the telescope is fully repaired, 100% operational. So we were happy. That was the best Christmas gift for all.
Yeah.
Anyway, I didn't go into details, but I can go more if you want.
Yeah, I have a question about it, about this, about the Hubble. One follower asks, how hard was it to handle Hubble with a robotic arm, and how did you feel during this maneuver? Did you feel tense or concentration?
I was assigned on this mission sooner than expected, because it was not yet my turn to fly again in space. And when the chief of the office called me, he told me, he started on a joke. He started to make me believe that I had made a mistake in the air on a T-38. It's a supersonic twin jet aircraft that we use for travel. And I was very concerned. And then he started laughing and told me, no, I want to assign you to a Hubble mission. Wow. And he said, it is not your turn, but we know you are one of our best astronauts for flying the robotic arm, and we want an astronaut ready to go within 6 months instead of 1 year of training. Normally we train 1 year for a space shuttle program. So I was assigned on this mission because of my specificity expertise on the robotic arm, which allowed me to get a very specific authorization from the flight director, which I was the only one to get. You are allowed to fly the robotic arm in course mode of velocity, because the robotic arm can be flown in 2 different modes. Very slow motion or fast motion. And there is a rule which says normally if you are less than 10 feet from structure, fast motions are prohibited. But I was so precise and I demonstrated such a master of my task that the flight director told me, you are allowed, Jean-François, for fast motion because I trust you to not put in danger the crew member sometimes attached at the tip of the robotic arm or to not damage the telescope. Mm-hmm. And the day before launch, Dan Goldin, the head of NASA, the administrator of NASA, came to visit us in quarantine the 18th of December 1999. And he said to all of us, you know, we just lost the space probe on Mars because of a stupid error of mixing units. We count on you to relight the image of NASA. And you, Mr. Clervoy, Billy Bob, that's my nickname at NASA, Billy Bob. And you, Billy Bob, when you are in charge of capturing the Hubble Space Telescope, I know that it will not be stable because it lost attitude control. Don't remember, remember that you will have $6 billion equipment in your hand.
Wow.
So we count on you to catch this wobbling Hubble telescope. So he tried to put the pressure, but he knew I was very at ease. And you know, sincerely, once I faced the telescope, I was told it was not going to be cooperative as opposed to all the other Hubble missions. And it was upside down instead of being upright. And it was wobbling, rotating slowly around itself. The instructors told me we cannot predict which orientation it will have because, you know, what had failed on the telescope were the gyroscopes. Those little spinners which equipment, you know, very small piece that turn very fast and help for pointing, fine-tuning orientation. And the commander of the Discovery wanted to stop Discovery exactly still relative to the telescope, but he couldn't do it because the only way to move the Discovery are with, you know, small rocket engines. You don't have so it's either too much up or too much down. So I was telling Kirk, you know, I feel fine. I can grab it even if it's drifting slightly. I'm ready. No, I want to give you a better telescope relative positioning. And after 2 minutes, 3 minutes, he told me, okay, Billy Bob, you have it. I cannot do better. And you know, I felt the robotic arm was like an extension of my own body. It was like my third arm. And without feeling, you know, under pressure, without finding the task too hard, I moved the tip of the robotic arm close to the telescope. I started to matching the drifting rates, the rotation rates. At the same time, I was closing towards the telescope. I grabbed it. I called on the radio capture. On the ground, they were very, relaxed, comment on dit, rassurés, reassured that everything was fine. And then I moved the telescope using fast rate. I made a pirouette with the telescope horizontally, then vertically, in order to fix it on a cradle in the cargo bay of the space shuttle. Quite fast, actually. And the ground controller in charge of the robotic arm was a bit, he was a bit concerned because I was very close to triggering velocity max rate alarm. But I stayed within my limits, and then we were ready to do the spacewalk the next days.
Now, I see we don't have a lot of time, so I will ask you perhaps what.
Maybe you will like shorter questions. No,
Yeah, yeah, no, that's
no,
fine.
don't hesitate to tell me. Since I see you, you can make a sign.
Okay,
If you
thanks.
want me to shorten my answers.
No, I have too many questions. That's the problem.
So we will take another rendezvous of Skype.
Yeah, perhaps. That would be great. Yeah, one or two question to conclude. Let's talk about your point of view about future human spaceflight. So, how do you see the human spaceflight in 10 years and in the future, aside from low Earth orbit, the Moon, and Mars? In your opinion, what will be the next big step for humanity in space?
I think we will probably never have any more one day where all humans are on Earth including on board aircraft. I think we will have always at least one or two humans in space. 10 years from now, there will be one big space station around Earth, the Chinese one, for research, open to international cooperation. There will be likely a smaller station for private business, for tourism, hotels in low Earth orbit. We will have again humans on the moon and around the moon, because a new space station will be assembled in the next decade around the moon. We call it the Gateway. It will be manned about 1 month per year, and sometimes one of the crew members will go to the surface of the moon. And I think that's the next big step. The next big step in the next decade will be humans will once again be far, very far from Earth. Still under the influence of Earth, because the moon is the satellite of Earth. But they will be in direct influence of another celestial object, the moon. They will orbit the moon, they will walk on the moon, they will work on the moon. And in the next decade after that, in the 30s, I expect the first human mission to go to Mars. Not on the surface of Mars, but flying around Mars and coming back. We can expect the first humans to go so far about 20 years from now. It will be the hugest step in humankind, even bigger than the first man on the moon, because for the first time, people will not see the Earth, will not be able to talk to the Earth in real time, and worst of all, won't be able to come back very quickly in an ultimate emergency scenario. From the beginning of human spaceflight, there has always been a scenario available in the checklist on board all spaceships since the Gagarin flight, how to come back to Earth now. From the moon, it took between 2 or 3 days. From low Earth orbit, from the space station, it takes few hours, maximum half a day. But once you fly towards Mars, whatever happens, you are committed to stay in space on board your spaceship for 7 months. That will be new. That's why I think the first mission to Mars will take another around 15, 20 years. And then after this first mission towards Mars, but not landing, flying around and controlling robots real time from the orbit, from Mars orbit, we will do robot control more efficiently than from Earth. Maybe in the 40s, we can expect the first humans to land and walk on the surface of Mars. And that would be big, big deal.
To conclude, I have a funny question for you. So you were in weightlessness, in the weightlessness plane with Usain Bolt. So were you faster than him in weightlessness?
Yes, indeed. I was lucky to fly in space with Usain Bolt last fall. It was a flight to demonstrate how a bottle designed and developed by MUMM was working in weightlessness to serve champagne and still respecting the AOC criteria. So many journalists were on board to attend the demonstration of how this bottle works. And Usain Bolt, being an ambassador of the MUMM champagne brand, he was on board and he was supposed to race back and forth under moon gravity, because in our plane we can reproduce not only pure weightlessness, but we can also reproduce the true real field of gravity like on the moon or on Mars. Not zero, but reduced gravity. And then with the design of the bottle, we decided, we should run with him. It's more fun. And then I said, yes, but if we run with him, we are used to weightlessness and to this aircraft. We will beat him. Yeah. And we said, no, he has to win. And actually, he has such wide, enjambé, comment on dit enjambé, he has such a fast pace with his long legs that he surprised us. And to answer your question, he won the race and the moon gravity, but we won the control of our body, because during the race he hit twice the ceiling. So if we count the criteria that the race must remain on the floor, we won.
Okay.
But if we count, the criteria was who was the fastest and the moon gravity to go back and forth using floor or the ceiling, he won.
Okay.
And he was very happy. You could tell in the video, he turns back, he sees us, the designer and myself, behind him. So he hit his chest saying, yes, I won. And then
so
we got champagne on board.
Yeah, you won the style contest. And you won the fastest way to...
He's the fastest man, not only on Earth, but also on the moon.
Okay. So, thank you very much, Jean-François, for this interview. This was great. And
thank you for asking those questions. I hope I was not too long, but anyway, if you want more answers to more questions, I'm happy to do it again.
Okay. Goodbye. Thank you, Jean-François.
Bye-bye.